Hi and welcome to today's webinar, the Valohai webinar. My name is Frederick.
Hi, I'm Ruksi.
Today we are going to talk about Kubeflow. So this is a hands-on showing what Kubeflow does and how to set it up, some instructions for you guys. At the end we also have some comparison of Valohai and Kubeflow.
Exactly. We'll be setting up like a local setup and showing the basic usage of pipelines.
All right, let's get started. A few slides first, then hands-on. So let's first start with Kubeflow itself. So what is Kubeflow? So Kubeflow is a Kubernetes native open source platform to develop machine learning workloads. Uh, this in practice, what it means, if you think about the mission behind Kubeflow, what they're trying to do, they're trying to be, first of all, infrastructure agnostic, meaning that you can set it up on your laptop, your machine learning rig, training cluster, production cluster. It works in the same way. It's built on Kubernetes. Its other mission is to help in deploying and managing loosely coupled microservices. This is very visible, for instance, in the pipelines part, where you can have different workloads, so-called microservices, working together or after each other. And finally, it should be scaling based on demand. So both in terms as inference as well as in the training case.
Yeah, exactly. Like the scaling based on demand comes from Kubernetes. That's the underlying technology
Yeah.
they use.
Yes. So actually that's a good point. Kubernetes or Kubeflow as a name also, there's a hint in the name. So the kube part comes from Kubernetes and flow comes from TensorFlow. So it's inspired by Google's internal way of running TensorFlow extended on top of Kubernetes. Um, it's built for production-ready pipelines. It's very sort of focused on production-ready. It's very focused on very large-scale models, which makes sense given Google's amount of data and machine learning models. In the beginning, it was built on GCP, Google's cloud, and a very TensorFlow-specific background as well.
Yeah, exactly. And some of the features don't even work on AWS or Azure, so it's heavily focused on GCP.
Yeah. However, today they do support multi-cloud environments. I mean, at least you can pick sort of, do I want to deploy it on Azure or even the local laptop here, as we're going to see. And today it also supports other frameworks besides TensorFlow. So if we then look at what does Kubeflow actually consist of, there are a few different pieces. It's basically lots of different open source projects. We think these are the most important ones. So Jupyter notebooks, of course, so that you can run code. Basically, you can choose the runtime environment when you're starting a new project. So let's say I want to run Jupyter notebooks on this GPU instance, this Tesla V100, instead of the CPU instance where we're actually sort of have the main UI for Kubeflow.
Yeah, and most likely our data scientists listening know what a Jupyter notebook is. So.
Yeah. TF Jobs, it's a custom Kubernetes resource for running TensorFlow models. Catlib is a hyperparameter optimizer, basically for TensorFlow, MXNet, and PyTorch. And pipelines, well, it's pipelining. You're going to see that soon in practice also.
Yeah, I'll show it up a little bit at least.
Yes. One important thing about pipeline still, it's basically defined in Python as it says here, but you can of course run any code on it. It's not Python specific per se.
Yeah, only the definition must be made on Python.
Yeah. All right, hands-on demo. Let's do it.
Awesome. Yeah.
Take it away.
I'll get cracking. So, for this webinar, I spent a couple days setting up like the command perfect script to set up a local Kubeflow. There are some requirements because I didn't like try it on Linux, Mac and Windows. But if you're working on Ubuntu or anything like that, this should work. It's a fully public GitHub repository, and I'll just walk you through it slowly. And like I mentioned, if I would to set it up, it would take at least, even with this script, at least like maybe half an hour. So I don't want to spend everybody's time.
No, of course, that would be boring for the webinar attendees. The GitHub link, we will post the GitHub link underneath the YouTube video after this as well, if you don't have time to write it down now.
Yeah, so don't worry about that. So first, I was trying different approaches to get Kubernetes running locally, and the most reliable and fastest one that I found on Ubuntu was micro Kubernetes. If you have Snap, which is a like a package management service and program, you can install it from there. Some notes: please use the 1.14 Kubernetes version. There's a version parity with micro Kubernetes and Kubernetes, so it's the Kubernetes version 1.14, and that's reason for that is that the latest Kubeflow doesn't really work on the latest Kubernetes. There's like manifest mismatches, so they're updating, like for example, what's the beta version of, let's say, stateful set, which is a Kubernetes resource, and it won't work on that.
So just that's a good point. Kubeflow has their own installation instructions also online, of course. This today is the best instruction available that we have in GitHub today. This is tested with the current versions here. So if you want to set it up, it's probably easier if you're watching this within a week from now to at least use this URL instead.
Yeah, this is
it might break in the future.
So I can vouch that this works.
Yeah.
And there's some services, so you need to enable the DNS for like the name searching, and then networking, and then you have the storage for like persistent volumes that you'll be using. Okay, you can use on the pipelines, and dashboard is a little bit extra, but you can use that for the Kubernetes debugging, so lower level stuff. Then there's more like micro Kubernetes setup, and then we download the Kubeflow control library. This is basically an installer or management software that allows you to download a manifest template from Kubeflow repositories, and then use that to generate the actual manifest, Kubernetes manifests to apply to your cluster. So we have this GitHub release URL here because we want to make sure that the version of the manifests will be from the exactly same repository that the installer itself. So there shouldn't be any parity. This, for example, is different on the official installation instructions. I also noticed one bug. So if we have this, like the latest version of Kubeflow, it's missing a definition to create Kubeflow anonymous namespace, which assumes that exists. Here's a link to the issue if it ever gets resolved. And then what we do is we use the Kubeflow installer library to first generate templates, then generate the manifests, and then apply it to the Kubernetes cluster. This applying, when you get to this point, it can take like maybe 5 minutes, but with some Kubernetes installations, for example, if you're going to use locally a virtual machine, that's going to take a lot longer most likely because it's less performant, but this takes maybe 10 minutes. I can show it on the console that it's at the moment running. So kubectl namespace kubeflow get pods, and we should be seeing, so we are seeing some pods running. So this is the like amount of different services and background processes that Kubeflow uses, and it's like mentioned, it's a collection of different open source libraries. Like there's, for example, the ML pipelines management. There's some MySQL, that's for the artifact storage, I think, or the metadata storage. Then there's the caddy hyperparameter optimization library and whatnot.
So there's actually a question here by Yuri regarding this also. Do you know, is it possible to deploy partially only Kubeflow, like only pipelines, without for instance, what else you had, a catlib, for instance?
Catlib, yeah. I wouldn't do it. Most like you can generate such manifests, but there could be some issues. I haven't tried it, but I can imagine it's possible, but I wouldn't do it.
Okay.
So
Okay, you're on your own, Yuri. Try it out and comment below if you get it working.
Yeah, because there's lots of dependency issues, so
Okay.
you cannot just take one of the open source packages away because it's a collection of like stitched together open source libraries, and they are expecting the other pieces to be
Okay,
there.
got it.
So at least that's my impression of it.
Okay.
Awesome. So then, and some notes about if you are running it locally, because micro Kubernetes doesn't rely on Docker anymore. They are using containerd for their container like running. The Docker like integration doesn't really work that well, so we are changing the execution engine. It's using different kind of containers called PNS containers or execution runner. Just a note about that. So if you don't see your pipelines getting up, that's the reason most likely.
By the way, if any of the actual Kubeflow team members are watching this at any point, happy to copy anything from here if that makes the setup easier.
Go ahead. Of course, like Kubeflow is a funny project. So last time I set it up was half a year ago, and it was totally different in my opinion. So it's so they're going so fast, and you know, mentality of going fast and breaking things. So it's always a new process of researching what works, but not.
Okay. Yes.
At least this works for now.
Yeah, I think they're at version 0.6 at the moment.
0.6.2.
Okay. Yes,
I think. Okay, so when you have your Kubernetes running locally, this is the main dashboard.
Or Kubeflow running.
Kubeflow, yes. So here's the namespace. So this basically if you can namespace your runs and whatnot by project or user, depending on the projects you're working on. I'll use the default Kubeflow anonymous. And then we have the main features that we at least partially discussed before. Artifact Store is the latest addition, or at least it has the latest changes regarding like what are artifacts. So now they can be also models and datasets, and previously it was more like visualization. So those are the three main artifacts that they consider artifacts are models, datasets, and visualizations. I haven't tried in fact the models and datasets, but the visualizations, basically you can generate interactive visualizations that you can store on the Kubernetes volumes or data stores.
Yeah, so here you can basically search and sort them then.
Yeah.
Today right now we have an empty project that we just started.
Yeah. So there's not much in here.
Yep.
Then we have the gated. I'm not going to run this, but this is basically used for hyperparameter tuning, like for TensorFlow, for example, and briefly just covering what it does. So you basically define what's the maximum amount of errors and trials that it's going to do, what's the value that it's going to optimizing, and do you want to minimize it, what's the expected goal, what's the algorithm to use, and what parameters are passed to the commands itself. So here you can say like try Adam algorithm or optimizer and so forth.
Sounds good. Looks good.
Yeah, it's a nifty open source library. You can also use this outside of TensorFlow.
Okay.
And then we have notebook servers. Everybody should be pretty familiar with notebooks. I'll just create one, but I won't be using it. Money spender, for example.
Yes, very good name. So basically here you're sort of starting up something that's going to use some more powerful CPU, GPU or something.
Yes, so here we can say how much CPU and GPU and memory it's going to use, and you can attach volumes, for example.
Yeah, basic stuff. You know how everybody knows how Jupyter Notebooks works.
Yeah. So I'll just start it, but leave it at there running. Yeah. And you can also use that notebook to integrate it Kubeflow, for example, like generating pipelines and stuff. But I'll just leave it at that.
Okay.
And this is the what I usually work with, like production pipelines.
Yes.
I have some examples about this. But first, what is a pipeline? Pipeline is basically a machine learning workflow that you are defining beforehand, and you can, for example, schedule it and produce something like a machine learning like models. Or you can also do experiments. The experiments in Kubeflow contexts are basically like a collections of relating pipeline runs. And it's an easy way, for example, to keeping your work, for example, if there's multiple users in the project, keeping your work separate so they don't mix up.
All right.
So in the Kubeflow example, if you are going to do this by yourself, there's also all of these guides, what I'm going to do. But on the project, there's pipeline examples. So here we have some really simple pipeline definitions. I'll take the second one, for example, with some details. What does everything mean, basically?
So here you can see that the pipelines are defined in Python in this case.
So we are using Kubeflow pipeline library. That's basically, they have this domain-specific language that they use to create operations that then get translated to YAML, that the Argo, which is the underlying execution runner, will use to execute. There's some funny things, for example, from time to time, you need to put some sleeves because the like the container monitoring doesn't have time to catch up with the container because it goes so fast. Because, for example, this is just reversing a string, so it comes in and goes out so fast, the container. So we need to put a little bit a second of sleep there. So here we define two operators. One basically reverses some text, and another one just prints it. Then we can basically tie these together. That okay, now here's a pipeline. We have a name, description of it. It takes one parameter, which is text, hello world, by default, and then we take the text, we reverse it, then use the reverse text to print it out, or print out the reverse text. And if this script is called by on its own, then it compiles it to basically a zip file that will contain a YAML file, which is the manifest how to run it on Argo.
Okay.
So I'll do that. So here we have locally the same project that I have online. I'll go to the pipeline side and remove that previous zip. Oh, I removed wrong file, but that's fine because I was going to use the second one anyway. So here we are going to do the output and input passing example. Here it is.
So it created a zip.
Yes, so it's this one. That's a previous one that I generated a while ago. And I can open it, and it has some pipeline YAML that has like more complicated definition how very basically Argo, which is the underlying runner, understands what's being done.
All right.
Awesome. So one way to upload it is use the upload pipeline and then upload a file. Of course, if it's online, you can just put in an URL. Here I select zip, I can name it, and then we have a new pipeline, like a blueprint basically. So here we have it in a visual form. It has the reverse, you can inspect it. On Kubeflow you cannot edit these on the fly, so you need to do the same thing again, that you compile and push it.
Okay, so basically it was defining it in the domain-specific language in Python, then compiling to the YAML, and, or basically compiling to the gzip file, which includes the YAML, and uploading that.
Yeah, exactly. And that's how it's done. And here we can see that it's a connection between the reverse and the echo. It's like the reverse text is used, that's generated by the reverse, is used by the echo. I'll just run it. Testing, no.
So this is actually creating the pipeline before we only had a blueprint for the pipeline.
Yeah, in Kubeflow terms, pipeline is basically the blueprint, and then there's pipeline runs that are just called runs.
Got it.
If I would have some experiments, I could say that, okay, this is part of that experiment, and then you can make it one-off or recurring. For example, if you have a like once a day training or something like that. And I'll just say hello there, webinar in here, and I will start the pipeline.
Do you know, Yuri is asking here, is it possible to upload a pipeline into Kubeflow and trigger a run via an API or
webhook? Yeah, they have a like Python API for that also.
Okay, yes.
It is possible. reverse, it doesn't print anything because we are just passing on the reverse text. And then we have a second one that basically uses the reverse text and shows it, prints it in a other way around. You can see that, okay, here we have the output from the previous one, and here's the input of the whole pipeline.
Yes.
So this is basically how pipelines work. You can also use it through the API, which is fine.
Yeah. All right. Should we go back to the slides and round things up?
Yeah, let's move forward.
So, shark attack warning. Valohai is a shark. So a short comparison between Valohai and Kubeflow, and then we have a bunch of questions for you guys, from you guys after that as well. So just quickly comparing, getting started with Kubeflow versus Valohai. You saw basically how to get started with Kubeflow. There's the official documentation on the left for Kubeflow. You can also use the GitHub repo with the instructions Ruksi has set up. But in terms of Valohai, just go to valohai.com, get started, hook up your own S3 buckets or Azure Blob Storage or GCP storages and start running it on your cloud. Second comparison, pipelines. On the left-hand side, you saw Kubeflow's pipeline. On the right-hand side, you can see Valohai's pipelines. Basically, the same thing, visualizing different pipeline steps, running them concurrently and in parallel and after each other.
Yeah, there's at least one major difference. Kubeflow is usually working on a specific Kubernetes cluster.
Yes.
On Valohai, you can, for example, let's say this is not a common use case, but if you have it, for example, I usually do work on AWS, but for some individual run, I want to, like a part of this pipeline, I want to run it on Google Cloud, for example, using TPUs.
Yeah.
Then that's possible.
So we have
multi-cloud.
Multi-cloud, but also on-prem hybrid cloud. So I think one typical use case is pre-processing data on the local server, passing that to the cloud to do some calculation.
For example, data anonymization or like handling sensitive data.
Yeah, and then you can again deploy into a completely different cloud or on-prem. So you can have different instances where you're running it. Yes, also this is a nifty feature. You can track the models that you've trained in Valohai. So you can see that this model.pb file, which is blue here in the middle of the screen, that came from the green dot number 4, which took in data from the green dot number 3, and which took in original data. So you can click around here and see the executions that have been passed, see where they have been done, what data was coming in. But you can also see this green dot number 5 on the right, which it could be like check for gender bias, for instance. So you can sort of prove these later on because you have this pipeline, this data traceability thanks to the pipeline as well. So this is a nice feature, I think, that we have. Hyperparameters, same kind of stuff here. You can define these different grid searches. Kubeflow has this own search algorithms as well implemented.
Yeah, implemented in Kati.
In Kati, yeah. In Valohai's case, you can use external optimizers through the API really easily. In Valohai's case also, you can sort of visualize these very nicely, so you can see sort of how over time these models are. If you're running them in parallel on 10 models on 10 different GPUs, you can see how they're converging in real time. Comparing Kubeflow's metadata to Valohai's metadata, in Kubeflow the metadata is tracked in code. Valohai gives you a bit more flexibility because you're not bound to any. In Valohai's case, you don't have to import any libraries. You can do your coding in Python, in C, in Java, in whatever language you want to. As long as you're outputting something in JSON format, as you see on the right here, Valohai understands that as metadata. So here we're tracking step and accuracy. You could track hundreds of these into the standard out as JSON, and it understands it as metadata.
Yeah. So in a normal Valohai project, you don't have to use Python. Of course, you can use Python, but you can just as well use raw C++, Unity, like C#, all those, because all languages have some kind of utility to bring JSON to standard out.
Yeah, exactly. And then this metadata, then you can visualize it as well. So you can visualize it in real time, you can visualize it afterwards. We're storing all the metadata, including the latest metadata, which gives you a chance that if you have done 10 different experiments, 100 different experiments, you can easily compare the latest value from there to see that which one has the best accuracy in this case. Or like if you have like 5 different variables or metadata you want to track, you can compare all of them.
Mhm.
Yes, tools that both support, so both support, of course, Jupyter notebooks, both have integrations. Valohai has a bit more integrations to Jupyter. You can run your Jupyter on one CPU, and then you can sort of only run the execution on the more expensive, more powerful GPU, and then it shuts down. In Kubeflow's case, we started the Jupyter notebook and it kept on running until we remembered to shut it down. In Valohai's case, it shuts down automatically after the run is completed.
Yeah. For like in technical terms, like Kubeflow basically offers hosted notebooks.
Yeah.
And Valohai doesn't offer that. Valohai uses Jupyter Notebook plugin. So the notebook that you want to integrate Valohai can be running locally or it can be hosted.
Yeah.
Both work.
Yeah. Then, of course, Valohai being more generic also because we can run, for instance, Unity code as mentioned, C++ code. You can run assembler 86 while true loops if you wanted to.
Yeah.
You can run anything that runs on top of Docker.
Yeah, for example, we have some use cases where people are generating images using Unity for like data augmentation and such.
Yeah, so you can have one pipeline step that generates that data, another in Unity in C, another pipeline step that does some transformation, or a third that does something more and so forth.
Yeah.
If we compare version control, Kubeflow has some rudimentary support for data version control with some manual work involved. Valohai automatically tracks the data, the code, the model, the pipelines, any IPyNB files, basically Jupyter notebooks, or even your cat images if you want to. So every execution is automatically tracked, so you can redo them 5 years later with the same code, the same data, same hyperparameters.
I guess the main point is that like Valohai is GitHub Git based, not just GitHub but any Git. So we do automatic like specific code commit like version control.
Yeah.
So you can easily roll back to any previous version of your machine learning training model. Or code.
Yeah. Even if you weren't using Git, if you're running code for your local machine, we take a snapshot of that code that was run.
So. Yeah, we take also a snapshot of what we call ad hoc runs, which are like one-off code.
Yes.
Runs.
All right. Comparing again integrations, Kubeflow integrates with Jupyter, builds on Kubernetes, runs in all these cloud providers. Valohai does the same thing, plus we support OpenStack also. We automatically support different data storages, basically storing the data, fetching the data.
Usually how like Kubeflow is used, that you handle the downloading of data, for example, yourself, like on the initial step of a pipeline. But on Valohai, you just need to point to a specific file and like it can be on any basically cloud provider storage, and we just handle the downloading and uploading everything.
Yeah. So your script will only pretend that it's working with local files, but in actuality, we're fetching the data and pushing the data once it's ready. So
So you don't need to use, for example, the Google Cloud's storage library to download anything. You don't even need to know about that. We handle all of that.
Yeah, you're playing with local files.
And basically.
Yeah. We support Active Directory, different GitHub, GitLab, Bitbucket, Docker Hub for hosting or private Docker hubs, and of course integrating into anything through an open API and a command line client.
Yeah. So how Kubeflow has it, you can also, of course, push on the YAML manifests, Kubeflow YAML manifests. So in that way, it has an API. The pipelines has an API, but not all of the pieces have APIs, at least as of yet.
Yeah. All right. Hey, let's jump to questions still here at the end. So we got a few questions from you already before here. So one of the questions was, you must have evaluated most platforms for performance with your ML solution. Yeah, we have evaluated a lot of different solutions. Kubeflow is a really good solution, especially taking into account its background, sort of building really big sort of models like Google is doing. It has some history in sort of being very Kubernetes and very TensorFlow centric, so it's not maybe as agnostic. We'd like to think at least that Valohai is the best solution for building custom models.
At least I think so. I have been like working with machine learning platforms of various kind for past 5 years, I think.
which is a long time in this.
Yeah, in this field, because I was working in San Francisco in like a machine learning company, and like I've seen dozens of these, and this is the like culmination of it, like all these features that they have. At least that's my opinion.
Yeah. You might be biased, but all machine
Of
learning
course I'm
models, your brain is
biased.
also biased. Yes. Second question was, does Kubeflow have support for scikit-learn models?
Yeah,
Of course.
yeah, on the like both on the notebook side and the pipeline side.
Yeah.
Works.
Then a third question was, what are infrastructure dependencies for installing Kubeflow? Somebody says that we found Istio and namespace are interfering.
Yeah, there's usually a lot of problems with the setup. It can take like easily a couple days to have like handle to all the errors. It's usually related to the Kubernetes version and the version of manifests you have, and there's some mismatch on that. But the basic dependencies of Kubeflow, didn't specify the version, so I can say for certain.
Yeah.
But usually it's a mismatch of the Kubeflow version, the manifest version, and the Kubernetes clusters version.
Yeah.
And top of that, what basically services or add-ons you have running on the Kubernetes cluster. But usually you just need the DNS and the provided like the storage add-on.
Yes, so if you think about like Linux terms, setting up Kubernetes hopefully is going to be like setting up Ubuntu in the future. It just runs when you start it up. Today it's more like Gentoo Linux in many ways, that you have to pick and choose in many places. It's not as bad. I happen to like Gentoo, but it's not as much manual work as Gentoo, but still.
Yeah, compiling your own like kernel yourself.
That's what all the tough guys do. Last question was that machine learning research architecture best practices. I guess sort of they're asking us about best practices for that. I think there's one thing that's very important, that is to pick the right abstraction level. So because machine learning changes all the time, there's new libraries coming out. Today we're doing things with TensorFlow. Tomorrow there's maybe an even faster, better framework. Today maybe you're starting out in using darknet in C and you want to switch to Python. You have to be able to support different tools. Today many people are using Jupyter notebooks. Tomorrow maybe just like running code from a local machine as scripts. 3 weeks from now they're using GitLab or GitHub or something like that to share projects. We have to pick the right abstraction layer to support everything.
Yeah, and especially in research, because they are the guys who are building these libraries, like the newest stuff, and they need to be able to experiment with, for example, new hardware like TPUs and VGAs and such.
Yeah. All right. Yeah, one question here also. Does Kubeflow offer version control for notebooks?
I don't think so. At least I haven't seen any. So basically you start just notebooks and then just shut them down.
Yeah.
There's no automatic version control.
Which Valohai then again has. So every run you do with Valohai through Jupyter notebooks automatically gets version control. So you can, which is a pretty nifty feature. You don't have to git commit anything. It just does it for you. I think that is it. If you have some more questions, post them in the YouTube channel below. We're answering them there. Otherwise, head over to valohai.com. In the top right-hand corner, there's a sign up. There's a free tier, free for life. Check it out. And if you have some questions, the intercom channel on the web page inside the app is there. We're always there answering your questions. So
yeah, and this was only the first like Kubeflow. So if you enjoyed this is like the scratch of the surface. So if you want us to do more, for example, webinars on Kubeflow or other like technologies like this, just write it down and we'll consider it.
Yeah, put the links here, or put the comments in the comments below also. And hey, remember to press the bell button, subscribe, so you get the notifications of new ones coming up. Thank you. See you again next time. Good night.
Bye.